Hi everyone, and welcome back to educator.com. In this mini lesson we're going to do the first page of the A+ Physics worksheet on electric charge. So let's dive right in. The diagram below represents two electrically charged, identical sized metal spheres, A and B. If the spheres are brought into contact, which sphere will have a net gain of electrons? Well, if they're brought into contact, what we're going to have is a transfer of charge so that we have 1.5 times 10 to the minus 7 on each of these. So we'll now have 1.5 times 10 to the minus 7 coulombs here, and 1.5 times 10 to the minus 7 coulombs here, assuming they're conducting. Now, if we go from plus 2 to 1.5 times 10 to the minus 7 coulombs, then that means this charge became less. It must have had more electrons on it. So we had a net flow of electrons from B to A. So which one has a net gain of electrons? The answer must be number 1, A only. Number 2, metal sphere A has a charge of minus 2 units, and an identical metal sphere B has a charge of minus 4 units. If they're brought into contact with each other and then separated, the charge on each sphere will be, well, when they're brought into contact with each other, the charges are free to move, so if they're identical, they're going to spread out as much as they can, which means you'll have minus 3 units on each sphere. Pull them apart and they can no longer move, so you're still left with negative 3 units on each one. Answer 3. Number 3, if an object has a net negative charge of 4 coulombs, the object possesses, well, if it's negative, it must have more electrons than protons, so we can get rid of choices 3 and 4. And let's convert that 4 coulombs into elementary charge just to see how many more electrons we have than protons. So we have 4 coulombs, and let's multiply that by, well, we know that the one elementary charge has a charge of 1.6 times 10 to the minus 19 coulombs. So that's going to give us 2.5 times 10 to the 19 elementary charges. Answer 2. Number 4, a lightweight sphere hangs by an insulating thread. A student wishes to determine if the sphere is neutral or electrostatically charged. She has a negatively charged hard rubber rod and a positively charged glass rod. She does not touch the sphere with the rods, but runs tests by bringing them near the sphere one at a time. What test result would prove that the sphere is neutral? Well, a neutral object can be attracted by positive and by negative objects. So I would say the test that would prove it is neutral is if it's attracted by both the negative rod and the positive rod. All right. In similar fashion, describe the test result that would prove that the sphere is positively charged. Well, the way to prove that something's charged is going to be with repulsion. So if you bring the positive rod near the sphere and you observe a repulsion, then the sphere must be positively charged. So use repulsion to prove something is charged. Positive, positive, you'll get repulsion. So the positive rod near the sphere, if they repel, the sphere must also be positive. Number 6, oil droplets may gain electrical charges as they are projected through a nozzle. Which quantity of charge is not possible on an oil droplet? Well, if you recall, the elementary charge is going to be our fundamental unit of charge. So we can only have charges that are integer multiples of the elementary charge. And the elementary charge is 1.6 times 10 to the minus 19 coulombs. So we could have that value. We could have twice that, 3.2. But there's no way to get 2.6 times 10 to the minus 19 by multiplying this by an integer. So 4 is the one that could not occur. Number 7. A positive test charge is placed between the electron E and a proton P as shown in the diagram below. When the test charge is released, it will move toward, well, the positive test charge will be attracted by that electron and it will be repelled by that proton. So in both cases, we're going to have a net force toward D. Taking a look at number 8. A metal sphere has a net negative charge of 1.1 times 10 to the minus 6 coulomb. Approximately how many more electrons than protons are on the sphere? Well, let's convert that charge to elementary charges. 1.1 times 10 to the minus 6 coulombs, and we'll multiply that by, we know that one elementary charge is equal to 1.6 times 10 to the minus 19 coulombs. Our coulombs will cancel out, and we should get something right around 6.9 times 10 to the 12th elementary charges, the number of more electrons than protons on the sphere. Answer 3, 6.9 times 10 to the 12th. Number 9. A positively charged glass rod attracts object X. The net charge of X may be, well, if a positively charged glass rod attracts it, X could be negative or it could be neutral. So it may be 0 or negative. Correct answer for 9 must be number 1. Number 10, the charge to mass ratio of an electron. Well, charge of an electron divided by the mass of an electron. The charge on an electron is 1.6 times 10 to the minus 19 coulombs, and the mass of an electron is 9.11 times 10 to the minus 31 kilograms. So what we're going to end up with here is about 1.76 times 10 to the 11th coulombs per kilogram. Answer number 3. All right, one more here. What is the magnitude of the charge in coulombs of a lithium nucleus containing 3 protons and 4 neutrons? Well, from the 3 protons, we get a charge of plus 3 elementary charges, and the neutrons have no charge, so that's going to be 3 times 1.6 times 10 to the minus 19 coulombs, or 4.8 times 10 to the minus 19 coulombs. All right, hopefully this went pretty well for you. If it didn't, take a few minutes, go back and look over our longer lesson on electric charge, and if it did go well, excellent. Let's go ahead and keep moving forward. Thanks so much for your time, everybody, and make it a great day.